This is the homework for 7-6, 7-7, 7-8, 7-9, and 7-11. For problem 7-6, we need to describe a sequence of rigid transformation that maps one onto the other. So there's a series of transformations that we can do to get triangle UVW to X, Z, Y. And there are many different ways, but the way I see it is I'm going to first flip or reflect triangle UVW over line UV. And so now you can see that I have my first transformation is U prime, V prime. And so I flipped or reflected it. Then I'm going to go ahead and rotate, because I want to get this image to look like this. I'm going to rotate triangle UVW prime at V prime. And now it's going to be UVW double prime. And then I need to slide it down because it has the same orientation now. So now I need to slide it down or translate it. And I can translate it to the right and down. And so now we can see this is going to go ahead and lead us to the second part. It says write a congruent statement relating the triangles. And so we can see that triangle UVW is congruent. This equal sign with a little squiggly line above it means congruent to triangle XZY. And this is how I did my transformation. The first translation would be to reflect triangle UVW over line UV, followed by a rotation. So we rotated it, and then we translated it, or slid it, to translation or slide, to the right and down. For problem 7-7, we need to determine if the two triangles are congruent. And I'm going to show you two different ways. One, we can use the Pythagorean Theorem to determine if the three side lengths are equivalent. So if these three side lengths are equivalent to these three side lengths. And then the other is using the Triangle Sum Theorem. And that's when the three angle measures are equivalent. And so if these three angles are equivalent to these three angles, the corresponding angles. And I'll go ahead and show you that in a moment. So the first I'm going to show you is using Pythagorean Theorem, a squared plus b squared equals c squared. And so on a triangle, the longest side is called the hypotenuse, and we're going to label that C. And so we have the legs, A and B, and then the hypotenuse. So we have the two legs of this triangle, which are A and B, and it doesn't matter which one you label A or B. I just chose 44. So we have A is 44 squared, 117 squared equals C squared. We want to find the length of the hypotenuse. And so 44 squared equals 1,936. 117 squared equals 13,689. And then to find, we still don't have the value of C, so we add these two together. The sum is 15,625. Still don't have C by itself, and so we have C squared. Well, in order to do the inverse property of squaring something, you take the square root, and that undoes the squaring. But what you do to one side, you do to the other. And so this cancels out because they're inverse properties. And so the square root of 15,625 is 125. So we get C, the value of C, equals 125, which is the hypotenuse. So we know that the length of this is 125. And if you look at the right angle here, it points to the hypotenuse. The C is 125. Well, if you look at triangle 2, the right angle is pointing to the hypotenuse, and the length of this side, which is C, is 125. So we know that the hypotenuse is the same, and we have one leg that's the same. And so we can also find the length of this side just to make sure that it's the same length as this side, which is 117. And I would go ahead and do that by, again, Pythagorean Theorem, a squared plus b squared equals c squared. And we have 44, which is the leg. So we have leg squared is 44 squared plus b squared. Well, this leg we do not have, so I leave it as b squared. But we do have the hypotenuse, which is 125 squared. And now we go ahead and simplify. 44 squared is 1,936. Same thing we got over here. Still don't have b, but we do know 125 squared is 15,625. And we got that over here, so it's looking good so far. Let's go ahead and find out what b squared is. Inverse property of addition is subtraction, so we subtract 1,936 from both sides, and we end up getting b squared equals 13,689. We don't want to know what b squared is, so the inverse property of squaring is taking the square root, and that will cancel out, but what you do to one side, you do to the other. And so we get b equals, and the square root of 13,689 is 117. So we get the length of b is 117. Well, that's what we had here. And we had the length of a is 44. And we know that the c, the length of c, the hypotenuse, is both is 125, because we have that up here. So all the lengths, the corresponding lengths, are equivalent. So we know that these triangles are congruent by using the Pythagorean theorem. The other way we can determine that they are congruent is by using the Triangle Sum Theorem. And what the Triangle Sum Theorem is, that the sum of any three angles in a triangle will equal 180 degrees. So if we know that, we can take the sum of the three angles, and we have 44, 69 and 39 hundredths, and x. And I'm going to go ahead and I have those three here. So we have the right angle, which is 90, 69 and 39 hundredths plus x equals 180. And we solve for x. We add these two terms, which we get 159.39. Want to get x by itself. Inverse property of addition is subtraction, so we subtract 159 and 39 hundredths from both sides. 0 pair. And we get x equals 20 and 61 hundredths. Well, that's the missing, x is 20 and 61 hundredths. Well, that's the same as this one, 20 and 61 hundredths. So we have 90 and 90, 20 and 61 hundredths, 20 and 61 hundredths. Well, if you know that these two are the same, the third one has to be the same. And so if we added 69.39 plus 20 and 61 hundredths plus 90, you get 180. So the triangles are congruent by the Pythagorean theorem. The three side lengths are equivalent, and by the triangle sum theorem, when you have the three angle measures are equivalent. For problem 7-8, we need to find the scale factor for when J enlarged figure A so it became similar to figure B. So if we know that it's going from figure A to figure B, so a small to a big figure. And the scale factor, to find the scale factor, it's the length of the new side. So this is the new side. He went from A to B, small to big, divided by the length of the original side. And A is the original polygon. So if we find the scale factor, we have length of the original side, length of the new side, which is 5, from the length of the small side, which is 2. So we have a scale factor of 5/2 or 2.5. Now, one thing to pay attention to is I went from a small figure to a large figure. So you know your scale factor has to be greater than 1 because it's increasing in size. If the scale factor was 1, 2 multiplied by 1 is just 2, and it would be the same size or the same length. If the scale factor is less than 1 but greater than 0, it's going to decrease in size. So you could find the scale factor from B to A. If it went the other way, it would be, this would be the new side, this would be the original, and you would have 2 divided by 5, which is 2/5. So when you're going from small to big, the scale factor is greater than 1. If you're going from big to small, the scale factor is less than 1, but greater than 0. The second part, part B, we need to find the value of x, the length of x. And so we can do that by multiplying by the scale factor. If we know the scale factor is 2.5, I could use 2/2, but I'd rather use in decimal form 2.5. I can go ahead and multiply 7 because that's the original, and it's going to be multiplied by 2.5. It's getting the length or value is getting greater. So 2.5, 7 multiplied by the scale factor of 2.5 is 17.5. So the value of x equals 17.5 millimeters. For problem 7.9, we need to write the equation of the line with an x-intercept of -4, 0, and a y-intercept of 0, 9. And we can do that. We know it's a line, so we use the formula equation of y equals mx plus b, slope-intercept form. And if we need to find the slope, we do know the y-intercept is 9 because it's given that x 0 on the x, 9 on the y. So the y-intercept is 9. We need to find the slope. And the way you find the slope is you can take the difference of the slope formula, difference of the y's divided by the difference of the x's. And so here's my first ordered pair. I was given the x-intercept of -4, 0, so x1 and y1, and then the y-intercept 0, 9, x2 and y2. So I have the difference of the y's, so this is y2, 9 minus y1 is 0, 9 minus 0 is 9, and then x2 minus, and I'm subtracting x1. So this is where it gets a little tricky. If I have x2, which is 0, and I'm going to subtract, I'm subtracting, and what am I subtracting? x1 is -4. So it's not 0 minus 4, it's 0 minus whatever x1 is, and x1 is -4. And what is the opposite of a -4? A +4. So we have the slope of 9/4. So our equation is y equals 9/4 x plus 9. Now, the other way you can do it is by graphing it. And so I took the x and y intercept points. The x-intercept is where the line intersects the x-axis, and that is at -4, 0. And the y-intercept is at 0, 9. And I drew a line through those 2 points. And then I just found the rise over run for the slope, and it rises positive 9, runs positive 4, which gives us 9 over 4. Remember, rise over run. And then the y-intercept, the b, is where it crosses the y-axis, which is at positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it also gives us the equation of the line by graphing it. For problem 711, we need to solve the system of equations. So I have these 2 equations, and I need to determine which method would be the best. And since I have what y equals, I can use the substitution method, because if I know y equals 3x, I can plug it in for y. I have 2 multiplied by y. What does y equal? Y equals 3x. So instead of y, I'm going to be multiplying it by 3x. Now I have 2 multiplied by 3x, which equals 6x. Now I can combine like terms. 6x minus 5x equals x, so x equals 4. Now that's only one part of the solution, the x value. Now I can plug it back in to either of these equations. And so here are the 2 equations, the original equations. And so to me, it's much easier, simpler to plug it into the top equation. And so I have 3 multiplied by x. Well, we know x equals 4, so I'm going to substitute x with 4. 3 times 4 is 12. So the solution to our system is 4, 12. And what does that mean? It means this is the only, these are the only values you can plug in for x and y into both of these equations to make this system true. Problem 711b, I need to determine which method would be the most appropriate to solve this system. And to me, I'm going to use the substitution method again, because even though it doesn't say y equals, I do know what y equals. Even though it's reversed, I have y equals x minus 4. So if I know that that's what y equals, I can plug it into the bottom equation. Because here I have 3 multiplied by y. What does y equal? Y equals x minus 4. So always remember when you're substituting a value in to put that value in parentheses, because especially when you have multiple terms, because this is a group. So I'm putting that in parentheses. And so now I need to distribute this 3. And so I have 3 multiplied by x, which is 3x. And then to multiply to the second term, 3 multiplied by negative 4 is negative 12. Now on the right side of the equation, I have like terms. I have 3x and I have minus 3x. Well, 3x minus 3x equals 0x. And then I still don't have x by itself, so inverse property of subtraction is addition. So I add 12 to both sides, and I get a 0 pair here, 0 pair here. And now I have x, 0 equals 0, because 0 times x is 0. And when you have one value equaling the same value, you have infinite solutions.